So, greetings students, I am Anand Kumar. Now, today I am present with the first lecture on software testing part. Now, before going into the lecture, I would like to acknowledge Professor Rajimmal. He is a professor in CSC department and from IIT Kharagpur. So, I would like to inform you that all the contents, all the PPT and the book that I am referring for the purpose of this lecture is being created by or is being provided by Mr. Professor Rajimmal sir. Okay, now let's move further in the discussion of the software testing part. So we have already discussed what is software testing. The brief discussion has been already provided by me to you all in the classroom program. Now let's move forward. So as we have already discussed, there are lots of coding effort made by the coder to implement the specifications that has been created in the design part. So as the coders implement the huge design documentation, there is some error which may get inherit in the implementation part. Okay, so as we know, as we execute some coding, some code part, then there may be a failure or there may be some issue which can get arised. So a manifestation of a fault, which is also called the defect or bug. Whenever a coder made some error during implementation, that error may lead to a defect or bug. So only presence of the fault may not lead to a failure. So what does this mean? Sentence means we'll discuss in the future. So a fault may create a failure or may not create the failure. Fine. So what is first error, faults and failure? We have to distinguish between these three. As we have already discussed that programming is a human effort intensive, therefore inherently error may get present during the implementation part. So in 1993, the IEEE standard has defined the error and the fault as the same thing. It was referred as the synonym. But as the testing part gets improved during the course of the time, so the IEEE revised the definition of error and faults. So to support more expressive communication, it distinguished between error and faults. Okay. So what is error and what is fault? It has been described clearly in this PowerPoint. So whenever there is, let's say in the specification part, if there is some error which may get inherit during the creation of the specification document. So once the error has been created or once the error has been inherent in this specification document, it may lead to some defect. Okay, so here all the error may not lead to a defect, and now this is the defect and all the defect may not lead to a failure. So some error may lead to the defect and some defect may lead to the failure. So we can understand it by a synonym. Let's say a programmer or the coder implemented, instead of implementing I less than equal to 50, he has implemented I less than equal to 500. So this is one of the error. But since the code is not going to use the value of I more than 50, so this error may not lead to a failure or this error may not lead to a defect. Okay, similarly it may not lead to a failure. So a few error fact, even even a most programmer who are the most experienced, they made a mistakes, and the 100 lines of code, if they are writing 100 lines of code, then 50 bugs may get inherit in those 100 lines of code. This is average for one of the experienced programmer. So extensively tested software also contains bugs. So if a code has been tested for a long period of time, it has been tested extensively, still there may be a bug, and the average bug is 100 out of 1000 lines of code. One bug may get present in that source code. So where does this bug or the fault present? So the 60% of the defect or the bug is present in the specification and design part, and 40% of the bugs are present in the implementational part. Fine. So how can we reduce the bug? Of course, by the testing phase, we have to we have some different methods that we can reduce the bug. So one is review, second one is testing, third one may be a formal specification and verification. The formal specification and verification may lead to a huge cost for a company. So it's not possible for a large code segment to go through this formal specification and verification part. And of course by use of some development process. So here we will be focusing only on testing part. So how to test? So of course if we have been given with the code, so how we can test? We can simply provide some data, provide some input to the code, and then we can observe the output. So this is one of the typical testing method. And we'll check if we are getting the output as per our requirement, as per our specification or not. So examination of the test result. If the program does not behave as expected, then we may say that there is a bug present in that code, and we can note all the conditions under which this test case or this code has been filled. So that is called the test report, and then we provide this test report to the developer, and later the developer debug and correct those defects. So here it has been mentioned, testing fact consumes the largest effort among all the development activity. So since only 10% of the work is 10% of the time is devoted for the testing purpose, but it consumes the largest effort among the all the development activity. Almost 50% of the development effort is dedicated for the testing purpose. So largest manpower among all the roles. It implies more job opportunity, since about we have already discussed about 50% of the development effort it takes, but only 10% of the development time. So how can we achieve that? We can achieve it by simply by the parallelism. So testing is getting more complex and sophisticated every year, since we are getting a huge number of codes year by year. More functionality needs to be implemented. So according to those requirements, the testing method should also get improved. So it's getting sophisticated every year. So it's getting complex. So larger and more complex program are there, and newer programming paradigm are there, and then also we need to take some testing automation. We have some testing tools like Selenium, JMeter, and other testing tool which require some skill and effort. Is more skill and effort than the manual tester. Okay. So what is the perceptions? The testing is often viewed as not very challenging. Initially, it was often treated as the less challenging, it was less preferred. But now, over the years, testing has taken a center stage in all type of software development. It's the main focus for all the companies. So, as we know, if we don't provide a good software to the client, then the company will not have its uh, then the company will not survive in the market, since it's not able to provide the proper proper software. So what is this monkey testing? So larger number of innovations has taken place in the testing area, requiring testing to have good knowledge of the test technique. So the monkey testing, earlier we used to perform the monkey testing. What is this monkey testing? So the challenges of the test automations were also there. So what is monkey testing? So there used to be a two type of monkey testing. Like one is a dumb monkey and second one is the smart monkey. So the dumb monkey, what does it do? It takes all the data, all the possible data. It provides all the possible data as an input to the software, and then it takes the output and analyze the output whether it's according to the specification or not. And second one is smart monkey, which only focus on the particular set of data. He already knows which types of data that code is taking as an input, and the smart monkey used to provide those inputs only. So here it has been what is the problem during this monkey testing. So the many programming parts may not get tested. Due to this, whenever we provide only input and we analyze the output, so there may be a case where many program part may not get tested. Of course, there can be a risk in involved if some part is not tested. So the risky area of the program may not get tested. The tester may not be able to reproduce the failure. Of course, the testing may not be able to reproduce the failure, since they are not able to provide the same set of data where the possible defect may get present. Here we have one of the very important concept in testing, which is called the verification and validation. Often you would find some questions in competitive examination on these two concepts, verification and validation. So the what is verification? It's a process of determining whether the output of one phase of the development conforms to its previous phase or not. Means whether we are developing a phase which is in accordance with the previous phase. Whenever verification is a concept which deals within the development process of the software, while validation is a concept which deals with once the system development has been totally completed. So here you will see validation is the process of determining whether a fully developed system conforms to its SRS document. Okay, so the verification is concerned with the phase containment of error, whereas the aim of validation is that the final product is error free, or the final product is according with the requirement of the customer. So here you can find where the verification and validation techniques are used. So whenever we are doing review, simulations, unit testing and integration testing, then verification, we are doing the verification part, and when we are doing system testing, then we are doing the validation part. Okay, so here is the difference between verification and validation. Are we building it right? Check whether an artifact conforms to its previous artifact, and it is often done by the developer, and its static and dynamic both activity are included in verification part, where as validation can be defined as have you built the right thing. If the whether we have developed a system, whether we have developed the right thing, whether it's accordance with the requirement of the customer or not. It checks the final product against the specification. It is generally done by the QA team or the testers. Dynamic activities are involved like execute the software and check against the requirements. Now moving to the testing level, there are generally four testing levels are there. One is unit testing, second one is integration, and then it comes the system testing, and then it comes the regression testing. So unit testing is generally done by the developer. So the developer, when developing a software, it is generally done in module wise. So whenever a developer develops a module, he usually tests that module. So that testing is called the unit testing. Then it comes the integration and system testing, whether it tests the system as a whole. Of it's done by the separate quality assurance team or the tester team. Once the different module has been completed, and then when all the module needs to be tested at once, that type of testing is called the integration and system testing. And then comes the acceptance testing, which is generally done by the customer. It's the validation of a system function by the customer. So these are the level of testings. The regression, here you can see the regression testing is done in the maintenance part. The unit testing is carried out in the coding part. The integration testing is done on the document, referring to the design document, and the system testing is carried out on the documents that has been generated in the requirement phase. And here you can see the acceptance testing uses the document which is SRS, or what we can say, what users really need, which is actually captured in the SRS document. So we'll move to the basic concept in the testing. For the before proceeding with any of the testing part of any software, we generally design the test cases. So that is called the test suite design. And then once the test suite has been designed, and in that phase we usually design the test scenario, the test cases, and then we go for the execution or the running of that test cases. After the test cases has been executed, we check whether the output of test cases conforms to the actual requirement, and if we find any difference in the actual output and the required output, then a failure may be detected through this difference. And then finally we prepare the failure report, which is then sent to the developer team, and then developer team debugs to locate the error, and then it corrects it. So this is the life cycle of a testing of a software. So here we have one question: as testing process, more and more bugs are discovered. Yes. So how do we know when do we stop? So see, testing is never exhaustive process. So it's not exhaustive process. Whenever you will think that you will start testing and you will able to find all the bug in that software, that is never possible. Okay. So you have to see when you have to stop. You have to decide of your own when you have to stop testing. So whenever you test that system, so whenever you start finding very less error, then you can decide to stop the testing part. Okay. Now it's the second question: is there give an example of the type of bug detected during the unit testing, the integration testing, and the system testing. So in unit testing, generally a logical type of error is found, and in the integration testing you will find some interface bugs, and in system testing you will find some performance related bugs. We will discuss in detail about all these testing, so don't worry as of now. So what is unit testing? We are When a developer has developed a particular phase, then he usually writes the function, and then he used to test that modular function that has been written, and that is being tested in separate way, in isolation way. So when if all modules were to be tested together, this is one of the question. What if all models were to be tested together? That is system testing. So it would become difficult to determine which model has error. So if we don't carry out the unit testing, so what can be the possible issue that a developer may face? So if a developer has developed all the model and then he will try to test all the models at once, so developer will not be able to, sometime he will not be able to figure out the error and in which model that error has occurred. So testing in isolation is must. That's why the unit testing is one of the important step for the developer. So it comes the integration testing. Once the model has been, many of the model has been designed, so and the unit tested has been done, so modules are integrated in the step according to an integration plan, and then the partial integrated system is tested at each integration steps. So if there are 10 modules to be developed and if the two module has been completed, so both of these two modules will be integrated first and then it will be tested, and in the next phase if 10 out of 10, if 4 of the module has been completed, so 2 earlier and 4 at this stage, so all the 6 module will be integrated and then integration testing will be done combining all these 6 modules. So integration and system testing. Integration test evaluates a group of functions or classes and identify interface compatibility, unexpected parameter value or state interaction, and runtime exceptions. And the system test working of the entire system. Okay, so here you will see one of the smoke testing. We'll discuss this smoke testing also. It tests the performance of a system. So system test performed daily or several times a week after every build. So often you will see it's to the analogy to the civil engineering. When there is a pipeline construction is there, so engineer what do they used to pass the smoke into that pipeline, and if they saw any leakage out of the pipe, then he can find out the hole in that pipe and he will able to rectify or he will able to weld those holes. So that this word has been derived from that part, the smoke testing. Okay, so what are the type of system testing? Earlier we have already discussed what are the functionality and what are the performance test. So the system testing is based on two of these tests. One is called the functionality and second one is on the basis of performance test. And system testing is also done who performs the testing. That is called the alpha testing and the beta testing and the acceptance testings. Often you would have you would have heard this alpha testing, beta software or the acceptance testing. So the alpha and beta testing is done, it is classified which of the people are performing this type of test. So the performance test determine whether the system or the subsystem meets its functional requirement, like response time, throughput, usability, stress, recovery, and configuration. So these types of requirement must be there in order to software to behave in a proper manner or behave in a efficient manner. If the response time of a system is not so good, so no one is going to use that software. Similarly, the throughput, the usability, and the stress should also be the system should able to handle those stress also. So these are the testing which is called the performance testing, and these are based on the non-functional requirement of a system. So what is user acceptance testing, which is also called UAT in short, and UAT also one of the important phase in the testing part. So the user determines whether the system fulfills its requirement, and it accepts or rejects delivered system based on the test results. So the UAT is generally done by the client or the representative of any of the client, with the presence of the one of the developer team and one of the tester team also. Fine. Who tests software? Program? Yes, programmers also do the testing, that is called the unit testing, and test their own or others programmers code. So user, yes, user also do their testing, and the test team, of course there is one of the separate testing for each and every organization. So which type of testing the testing team does? All types of testing except unit testing, beta and acceptance testing. First, developer test plan and strategy. Develop test plan and strategy, and then it carry out the testing. So user generally test the usability and acceptance testing, and volunteers are frequently used to test beta versions. Here it comes the verification and validation, V&V. So the review and simulation, that is done in the verification part, and it is done within the phase which is either it can be requirement analysis or design or coding phase, and testing by developer and testing by the tester, that is done in the coding and testing phases respectively. So what is pesticide effect? Error that accepts a fault detection technique cannot be detected by further application of that technique. So whenever we have used one of the technique to figure out any defect in the system, and the next stage, if we apply that test strategy, then we may not be able to find some type of bug. So error that accepts a fault detection, if it if a error detects the fault detection using some technique, it cannot be detected by further application of that same technique. This is called the pesticide effect. So the Crapper-Jones rules of thumb: each of the software review, inspection and test step will find 30% of the bug present. Okay, so each of the software review in inspection and test step, it will be able to find the 30% of the bugs present. So more and more review inspection will be done, and more will be able to find the bug, but it doesn't mean that we'll always perform this type of testing. So we have to stop at some point of time. So the assume to start with 1000 bugs, and we use 4 fault detection technique. Each detects only 70% of the bugs existing at that time. So how many bugs would it remain at the end? So see, this is 100 into 0.3 into 10 to the power 4 equal to 21 bugs will be remain at the end. See here, you will able to find if we are using the 4 fault detection technique, and see 70% of the bugs are existing, and 70% bugs has been found out, but the 30% bugs will not be able to find. So the 30% will get propagated for the next technique. So this is the formula, this is the thing how you can find the number of remaining bug. 1000 into 0.3 into 0.3 to the power 4 is equal to 81 bugs will be the final answer. So when are verification undertaken in waterfall model? These are the question for you all. So question number 1, when are verification undertaken in the waterfall model? When is testing undertaken in waterfall model, and when is validation taken in waterfall model? These are the questions that you have to answer of your own. So after the testing is complete, so the several independent study, what does it suggest? 85% of the error gets removed at the end of a typical testing process. Why only 85%? Why not more? So all practical test techniques are basically heuristic. They help to reduce bugs but do not guarantee complete bug removal. So whatever the testing tools or techniques present at present, they are in the heuristic nature. They do not guarantee the complete removal of the bug from the system. So now let's move to the next concept, which is called the test case. So each test case typically tries to establish correct working of some functionality. So whenever you have been assigned with some of the functionality or some of the software model, so you have to write some test cases on which that model needs to be tested. So you will write a test case which correctly which stipulates correct working of some functionality, the functionality which you have been assigned with. So you have to cover some program element in that module, and for certain restrictions type of fault based technique can also be used. So what are the test data that you need to provide for that test cases that you have to identify before executing that test case? And in test case, input to test of the system. So whenever you have been assigned with a test case, you have to identify some test data that a particular test case will take as an input. Okay, so in test cases, input to test the system and state of the software. So test cases and test suited. What test suits? A test case is a triplet. ISO. I is the data to be input to the system. S is the state of the system at which the data will be input, and O is the expected output of the system. So input, system, and output. Input state or input system or output. So whenever you will provide some input to the test cases, and you have to provide some environment, or you have to provide some type of state for that test cases, and then you have to record the output. For test cases and test suites, a test of software using a set of carefully designed test cases. The set of all test cases is called the test suites. So whenever you will write some test cases, so all the test cases that contains in either in the Excel sheet or in a module that can be treated as a test suites. And there are some, now we are discussing here the test cases. There can be some different types of test cases. So it can be either negative test cases, it can be either positive test cases. So you have to also write some negative test cases also in order to find whether we should get some error or we should get some negative output from this system. Whenever let's say we are designing a system and we are saying that it should not respond to the value at -1. So what we will do, we'll just provide the value as a -1 to that system or to that model, and we'll see whether that model is reacting in accordance to the requirement or not. It should generate the error. That type of test case is generally called the negative test cases. So if user, here you will see the example, if user types letter in a numeric field, it should not crash but politely display message incorrect data type, please enter a number. This type of test cases is called the negative test cases. Test execution example: set the program in the required state, book record created, member record created, book issued. So these are the set of program in the required state. Okay, give the defined input and then you have to observe the output. Okay, first you have to set the environment, like you have already created some member and then you are giving the input, and then you should get a proper output in accordance with that the state that you have already defined. So test number, test author, so these are the fields that the test suites should contain. Like whenever you are writing a test suites in or test case documents, so these are the fields that you need to mention, like test case number, who is the author of this test cases. So see, a testing team may have many of the test designer, so they would write the test cases, and finally these test cases are integrated in one of the Excel sheet. So the test author must also be written over there in order to identify who is the author of this or has the designed this test cases. So the purpose of test cases is the purpose of test cases should mention the preconditions, what are the test input that this test case required, the expected output, the post condition, the test execution history, test execution date, the person executing, who is the executing that test case, that should also be mentioned in that Excel sheet. So see, all these fields are the fields in a test case document. Test case number, test case of the test case purpose, and beneath this all the test cases are recorded. So the test planning is done by the experienced people. The test scenario and the test case design is also done by the experienced and self-qualified people. Now the test execution is done by the semi-experienced to the inexperienced person. And finally the test result analyzed by the experienced people. And what are the test tool support that required the execution of the test case is provided by the experienced people. It may include external people also, like user or industry experts. So thank you. We'll meet for the next lecture. Thank you.